So now we're going to do function operations involving expressions. So again, you have the open circle. So I know this means I'm going to take f of g of x. So what I need to do is I need to take function g of x, which is defined as 4 over 4 minus x, and I'm going to take x out of function f, and I'm going to replace it with this entire expression. Remember, this is now going to be an input. So again, f of 4 over 4 minus x. So I'm taking x out of function f, and I'm replacing it with this entire expression. So now I'm going to have 6 over 2. I'm taking out my x and replacing it with the 4 over 4 minus x plus 1. Now when they talk about the domain when you're dealing with composition, you have to look at two places for the actual domain. You have to look at your input function and your final answers domain. So the domain of this function, I know I can't have 0 in the denominator. It's going to be all real numbers except 4. So when I talk about the domain, I cannot include 4 in the domain. So now I have a complex fraction to simplify. So what I'm going to do is multiply everything by my LCD. Remember, to simplify any complex fraction, you multiply by the LCD. So in the numerator, I now have 6 times 4 minus x over. When you multiply by the LCD, the 4 minus x is going to cross cancel out. 2 times 4 is 8, plus 1 times 4 minus x. So that gives me 6 times 4 minus x over 12 minus x. So then I can't simplify because I do not have that 6 with an x in the denominator, so this is going to be my final answer. So the domain is going to be all real numbers except 4 and 12. No, you're not.
Are you sure? Can I make one?
Yes, you can.
Am I allowed to eat today? Can I eat or?
So like I said, when you're asked about the domain and you're dealing with a composition of functions, you not only have to look at the input, that's where we got the 4 from, but you have to look at the domain of the final answer as well. And again, because you have a fraction, we know we can't have a 0 in the denominator, so all real numbers except 4 and 12 have to be, so 4 and 12 have to be excluded from the domain. Remember, composition of functions is not commutative. In other words, f open circle g we know as f of g of x. Well, g f of x is not necessarily equivalent to f g of x. So remember, this is actually equivalent to g f of x. So f of x, remember, is this 6 over 2x plus 1. So I'm going to take out my f of x, and I'm going to replace it with 6 over 2x plus 1. Again, when they're asking about the domain, I've got to look at the domain of the input function. So I have to set the denominator equal to 0. So I know the domain of this function is going to be all real numbers except negative 1/2. So I know that negative 1/2 cannot be in the domain of my final answer. So now what I need to do is I need to take my 6 over 2x plus 1 and plug it into function g. So I have to take my x out and replace it with the 6 over 2x plus 1. So you have a complex fraction, so you have to multiply everything by 2x plus 1. So the numerator is now going to be 4 times 2x plus 1 over, I have the 4 times 2x plus 1, so I'm going to distribute to that. That's going to give me 8x plus 4. Again, this 2x plus 1 is going to cancel. It's going to give me a minus 6. So when I simplify the denominator, that's going to give me negative 2, 8x minus 2. Now notice you want to make sure your final answer is in simplest form. I can divide a 2 out of the 4, 8x, and minus 2. So it's going to be 2 times 2x plus 1 over 4x minus 1. So that's my final answer. Again, when you talk about the domain, you've got to look at the domain of the final answer. Again, you can't have a 0 in the denominator. So the domain is going to be all real numbers except negative 1/2, and 1/4. So that's your composition of functions. So now we also are going to talk about how we can solve different types of quadratic equations. So these are giving me an example of to solve by completing the square. Remember, the first step is you want to take your constant and move it to the other side. So you only want to have your x's on one side. And I'm just going to put a blank here and a blank here. So to complete the square, we want to actually create a perfect square trinomial on the left-hand side that I can factor. So to get this perfect square trinomial, I'm going to take -16, and the formula to complete the square is you divide by 2 and you square it. So -16 divided by 2 is -8, and -8 squared is 64. So I'm going to add 64 to both sides of the equation. You should be able to factor this particular trinomial into a binomial to the second power. That's what a perfect square trinomial factors into. Factors of 64 that add together give you -16. It's whatever number you squared right here is, which is going to give me x minus 8 equals 60, because you have to add -4 plus 64. Now you can finish solving by taking the square root of both sides. So x minus 8 is equal to plus or minus square root 60. I can add 8 to both sides, so x is equal to 8 plus or minus. Now you can reduce square root of 60 because you break this up into 4 times 15. So that's going to give me 2 times square root 15. Now when you're completing the square and you see a number other than 1 in front of x squared, you need to first divide out whatever that coefficient is. So I have x squared minus 5x minus 2 is equal to 1. So now I'm going to do exactly what I did in the first step, is you want to move the constant to the other side of the equation, leave a blank here, and when I add 1 plus 2, that gives me a 3. So to complete the square, I have to take -5, divide it by 2, and square it. So that's going to give me 25 over 4. So I have x squared minus 5x. I have to add 25 over 4 to both sides of my equation. So I have to take 25 over 4 and add 3 to it. So I know that I need a common denominator, which is going to give me 12 over 4. So that's going to give me 37 over 4. When I add 25 over 4 plus 12 over 4. I can factor this. Again, remember, whatever number I squared is what this factors into. I'm going to take the square root. So I have x minus 5/2 is equal to plus or minus. Again, remember, when you take the square root of a fraction, you take the square root of the numerator and square root of the denominator, and I know square root of 37 is, square root of 4 is 2. Then I can add to both sides. So x is going to be equal to 5/2 plus or minus square root 37 all over 2. So that's how you can solve by completing the square. Next, they're asking me to solve by factoring. So all your different techniques of factoring. Remember, when you solve by factoring, you always want to have a 0 on one side. So again, you have a trinomial where the leading coefficient is not equal to 0. So some of you may use the m method, the x method. So whatever method that you use, that's completely up to you, but you should get the same answer again. So this should factor into 5x minus 2 times 3x plus 1. So then when I set each factor equal to 0, I end up with solutions being equal to x equals 2/5 and -1/3. Remember, the first thing you look for, again, we have a 0 on one side, but you always want to look for a GCF. And notice you can pull out a 2x out of every term on the left-hand side. So that's going to give me an x squared minus 7x minus 8. and then the factors of -8 that add together give me -7. It's going to give me x minus 8 times x plus 1. Now, since your GCF had an x in it, when I go to set each factor equal to 0, I have to take 2x and set it equal to 0, in addition to the x minus 8 equals 0 and x plus 1 equals 0. So x is going to be equal to 0, 8, and -1. Here you have a binomial. You have a difference of squares. Hang on. So this is a difference of squares. So I can take the square root of 64x squared, which is an 8x, square root of 81, which is 9. So 8x minus 9, 8x plus 9. So x is going to be equal to 9/8 and -9/8 when I set each factor equal to 0. Now when you want to solve by isolating the square, you want to get whatever base is raised to the second power all by itself, and then you can do the square root. So the first step is going to be to add 5 to both sides. So 19 plus 5 is 24. So you need to divide by 2/7 or multiply by 7/2. So let's see, 2 goes into 24 12 times, and 12 times 7, I believe, is 84. And then I can do my square root. Don't forget your plus or minus. And you can simplify 84. 84 can be simplified to 4 times 21, which is 3 square root 21. So x is going to be equal to 2 plus or minus 3 square root 21. And I think that's, I'm sorry, it should be a 2 square root 21. Because it's 4 times 21, that's 81. Get the x squared by itself, so I'm going to add 45 to both sides. I'm going to divide by 5. And then I can take the square root, so x is equal to plus or minus 3. Get the x squared by itself, so my first step is to add the 8. So 8 plus 12 is 20. Divide by 2. X squared is equal to 10. Take my square root. X is equal to plus or minus square root 10. So there's lots of different ways you can solve quadratics. Just the other examples I told you, the different methods, now it's up to you. So when I see 9x squared minus 100, what I would do is I would get x squared by itself and do the square root method just like I did in the previous two examples. So 9x squared is equal to 100. Divide by 9. X squared equals 100 over 9. Now remember, when you take the square root of a fraction, you take the square root of the numerator. Square root of 100 is 10. Square root of 9 is 3. And don't forget your plus or minus. Unfortunately, you can't factor b. So what I would do is I would use completing the square. So my first step with completing the square is I'm going to add 4 to both sides. Then, to create that perfect square trinomial, I take -12, divide it by 2, and square it. So that gives me -6 squared, which is 36. So I'm going to add 36 to both sides. So I can factor this into x minus 6 squared is equal to 40. 4 plus 36. Now I'm ready to take the square root. I can reduce square root of 40 to 4 times 10, so that's plus or minus 2 square root 10. So x is going to be equal to 6 plus or minus 2 square root 10. So now when you take a look at C, you have 6x squared minus 7x minus 3. So what we want to try and do first of all is I would try and see if I could factor this. So using your n method, your x method, again I'm going to try and use slide and divide. So the way slide and divide works is take 6 times -3, which is -18. I can factor factors of negative 18 that add together give me negative 7, or x minus 9 and x plus 2. Divide by that leading coefficient that I dropped, the 6. Reduce your fractions. Again, you can use whatever technique you feel most comfortable with. So this factors into 2x minus 3 times 3x plus 1. So x is going to be equal to 3 over 2 and negative 1/3. So that's how you can solve quadratics by factoring.